Good day, I am Mr. van Niekerk. This is a lesson for grade 9 on whole numbers. So to begin with, we start by looking at the fundamentals of numbers, and we're going to look at all the different types of numbers that we use whenever we add or subtract or multiply or divide. Whatever we do with numbers, these are the different types of numbers. So the first question we have now, what is whole numbers? Well, to start off with, it's not when you dig a hole and you throw numbers in them. No, that's not whole numbers. All right. So what's whole numbers? Whole numbers is actually any number that we use in our daily life, any positive number, and including zero. For example, how many brothers or sisters do you have? Let's say, how many brothers or sisters do you have? Well, maybe you have 2 brothers or sisters. Maybe you have 3. Maybe you have 0 brothers or sisters. All right? Do you see? It's a number we use in everyday life. Or how many children does your parents have? Okay, let's say children. Well, maybe it's only you. Only one child. Or maybe your parents have 4 children. All right? It's any number that we use. When you go to buy something at a shop, and the cost for a Coke is how much ever it costs. Let's say 11 rand. Okay, that's also a whole number. All right. So for any of these, for how many brothers or sisters you have, you won't have -1 brothers or sisters. Okay, so -1 won't work. Okay, that's not a whole number. All right. How many children does your parents have? You also can't say no. You have they have -4 children. Okay, that's not a whole number that's going to work. Also, you're not going to buy a Coke for -5 rand, for example. Okay, so these ones are not whole numbers. Let's do it like that. Those ones are not whole numbers. So whole numbers are not negative numbers. Right. So let's look at all the different types of numbers in the real number system. Right, let's go here. So we're looking now at whole numbers and the fundamentals of numbers. Right, so we are going to have 2 main categories. I'm sure you've seen this before. You should have seen it in grade 8 already. We're basically recapping and starting from the basics again. Okay, from the fundamentals again. Right. So first, okay, we have these 2 different types of categories. The first is I hope you can remember this, the real number system. All right, let's write it here. So we have real numbers. Okay, I'm not going to write numbers every time after the word, just to save space. And the symbol for real numbers is sort of an R. It looks like this. So it has 2 stripes on the left. Okay, and that's the one type of number that we have. And then the other one is the non-real. Right, non-real numbers. And the symbol for that is also this R, but with an apostrophe. All right, so it means it's not real. It's non-real numbers. All right, so we have these 2 main categories. Now, do you see? I drew this table view starting from the bottom. So I want you to think of it as a building. Right? You can't start building a building from the top. Okay, you can't build the top floor first and the penthouse and everything, in a hotel that's at the top floor. You have to start at the bottom. All right, you have to get the bottom floor first, and then from the bottom floor you can build the second floor, and then the 3rd floor and 4th, until you've built the whole building. Right. So inside the real number system, we get now rational and irrational numbers. So we can write this down here as well. we're going to do examples of what these numbers look like. So let's write here rational, and the symbol for rational numbers is a Q. All right, that's your symbol for rational numbers. And the other type of number inside here is irrational. Okay, irrational numbers, and the symbol for irrational numbers is again the Q, but now with an apostrophe. All right, rational numbers, irrational numbers. Right, let's look at inside. Let's go with irrational numbers first. It's the shorter ones. Inside irrational numbers, we get a few different types of numbers. These are the odd types, numbers you don't see every day or use every day. Right, we have surds. So I'm going to write it over here. Let's say we have a surd. Now a surd, let's use a different color here. A surd is any number inside a square root when you don't get a number as an answer. All right, you get a decimal number actually. So a surd would be, for example, the square root of 5. Right. If you take the square root of 5, if you insert it on your calculator, you'll get some decimal number. All right. Also, even let's say square root of 7. Right. Numbers like that, where if you type it in your calculator, you get a decimal number. All right. So we have surds inside irrational numbers, and then a non-ending or never-ending and non-recurring decimals. So let's write it here. I hope I have enough space for all of these. Let's write never-ending. Right. These are numbers or any type of decimal number where you have, let's say, for example, 1,34715. There's no pattern that it follows. It just continues like that. All right. It's a number that never ends. All right. And the other one is it's also a non-recurring number. There's no pattern inside this decimal. All right. So we can say it's a never-ending number, or a non-recurring number. We can write that as well. Let's see. Let's write it up here. Non-recurring. All right. So it's one of these two. Okay. Right. We can finish the building at the end. Let's just get through all the different types. So these ones are all part of irrational numbers. All right. Now, let's say this was now the first floor. Okay. We've got the basis of the building, and then we've got floor 1. Right. Now let's go to floor 2. Right. On floor 2, now inside irrational numbers, we get integers. All right. And okay, let's just write that, integers. Right, the symbol for integers is a Z, like this, that has 2 stripes on the diagonal. All right, it's a Z, integers. And these are numbers, any number without a decimal, if it's a positive or a negative number. So it can be any negative number, negative 10, negative 3, right? Including 0. 0 is also an integer. 1 and any other positive number where we do not have a decimal. All right. Inside integers, then we get whole numbers. So here we have whole numbers, and the symbol for whole numbers is an N, right, with a double stripe on the diagonal, and a 0. All right, because with whole numbers, it's any positive number, including 0. So it starts from 0, 1, 2, 3, etc. Right, until positive infinity. Right, then inside whole numbers, we get natural numbers. So we have natural numbers, and the symbol for natural numbers is just an N. All right. An example of these are just, well, we start now from 1, so there's no 0, and we continue till positive infinity. All right. So this is all the real numbers. Let's just look quickly at, are there decimals with rational numbers? Yes, there are decimals. So we do have decimals, you see, with irrational numbers. Okay, we saw there's decimals if we get the surds and the non-recurring and never-ending numbers. But there's also decimals with the rational numbers. These would be, let's see, numbers like fractions. All right, we have fractions over there. We can write, okay, let's just write, for example, 2 over 3 is a fraction, all right, which is also, in this case, a recurring number. All right, so we also have recurring numbers on the rational side. We have recurring numbers. Any other fraction, 1 over 4, 3 over 8, all right. Any normal fraction like this, where if you take, for example, 2 over 3, and you turn it into a decimal number, what would it be? We get, from there, we can get 0.6 repetitive, all right? The 6 is just going to continue until infinity, all right? So the difference with the decimal numbers between rational numbers and irrational numbers is that when we have a decimal number with rational numbers, it's a recurring number. All right, with irrational numbers, it's a non-recurring number. Or we can say that there's perhaps a pattern that it follows. For example, we could also say here 0.2727, right, like that, 27. So that also goes until infinity. There's a pattern that it follows with rational numbers. But with irrational numbers, there's no pattern that it follows. Right. Let's just take this one away over here, just so that we can draw our building nicely. All right, now, so the building that I talk of, to complete it, we have it now like this. All right. And we have these different floors. So remember, you can't have the top floor if you don't have the bottom floor first. So it means if you have any natural number, it will also be a whole number, and it will be an integer, and it will be a rational number, and a real number. All right. If you have any whole number, it will also be an integer, and a rational number, and a real number. Right. So if you have the top one, it will be all of the others below it as well. Okay. If you have the top one, you have all of the others below it as well. But you can't say that you have the bottom one, you have a rational number like this, a fraction. Now it will be also one of the others above it. That will never be like that. That's why I give you this in the shape of a building, in the form of a building. You have to have the bottom one first, and then you can have the top one. So in order to have something from the top, it means it will be all the others as well. All right, not the other way around. Just quickly to look at the non-real numbers. These are generally numbers that you won't work with a lot. The most common one that you work with non-real numbers, especially in grade 9, would be, no, you don't work with them. You'd only work with irrational numbers in grade 9. These ones would be like pi. All right, that's also an irrational number. But non-real numbers, you don't have to worry about that. That's a number, for example, like if you have inside a square root a negative number. All right. Anytime there's a negative number inside a square root, it's actually a non-real number. That's all that you actually need to know for now about non-real numbers. Right. So this is the real number system that we use all the way until matric. You can look in your Platinum textbook for grade 9s. It's on page 4. There's also an explanation of that. They give it a little bit of a different way, tree diagram. Whichever one works the best for you is fine if you use that one. And then on page 6, there's an exercise. I wanted to do that exercise 1.1. I'll do an example with you quickly. We can look at, let's just get a new page here. So you see homework will be there. That's now for tomorrow, for Tuesday. Exercise 1.1, page 6, number 1 to 5. All right. Remember, maths is practice. You have to practice maths just as you practice any muscle in your body. Right. Those of you playing soccer or any other sport, you're not going to get better at soccer by sitting next to the field and watching your friends play soccer. Right? You're going to get better at soccer and your skills will improve and your fitness will improve when you practice yourself, right? When you are on the field and you're busy practicing. Now that's the exact same way how maths works. You have to practice. You can't watch somebody else do it, or you can't watch me do it and say, oh yes, you understand. You have to practice it yourself. So just quickly, for an example, on exercise 1.1, let me just write like that, just so that you know what's going on there. Right, it says at number 1, decide whether the following numbers are rational or irrational numbers. Right, remember rational, irrational, these ones? Okay, rational, irrational. So we're looking at all of these types for rational, including the fractions and the recurring decimals. For irrational, it would be surds or never-ending numbers. Right, so if we go to 1.1, let me just give you an example of maybe I should just give you one or two of these. You can write down the rest. So you can write it like this. Sorry, that's real numbers. We're working with rational, right, and irrational. Right. So remember the apostrophe with a Q is irrational numbers. Right. So an example for rational numbers from number 1 would be, let's see, let's take the first one. Square root of 25. All right, what's the square root of 25? Yeah, 5. All right, so that's actually a rational number because 5 also fits into natural numbers. All right, and natural numbers fit into whole numbers and integers and rational numbers. All right, so square root of 25 is a natural number. It's a rational number. All right. Let's see for an irrational number. Which one can we take? Irrational. Well, the easiest one for that would always be pi. Right, that's an irrational number. If you type pi in your calculator and you say equals, then you get some non-recurring, never-ending decimal number. All right, so it falls in. It falls in this category. You see, pi is also a non-recurring number because the decimals just keep on going and it never ends. Right? There's no pattern that the decimal numbers follow. Right? So that's just two examples for a rational and an irrational number. Right? There's many others. You can go type them in your calculator and see what you get. see whether you get a decimal number that ends or has a pattern, then you know it's a rational number. If you get a decimal number, like with pi, that doesn't end and there's no pattern, it's an irrational number with an apostrophe. All right, that's it for today. And remember, please do your homework. Have the integrity by yourself. I can't check your book every day, hopefully, and maybe you have a parent or someone at home that can check your book or can assist you if you have a question as well. But you have to practice. Okay, if you want to get better at maths, or if you want to get better at any sport, at soccer or whichever sport you like, okay, you have to practice. Okay, so maths is practice. Right? Maths is practice, and the more we practice, the easier it gets. Hey, imagine you run a 5-kilometer race and you're not fit at all. Right? It's going to be a very, very tough race. Okay, but imagine you are at the top of your game, you're extremely fit, and you can run a 5-kilometer race inside 20 minutes. Right? Then it won't be that bad. Right? Afterwards, you'll maybe catch your breath within 5 minutes, and then you'll be fine again. Okay, so it gets easier the more we practice. Okay, then we can understand better, we can push harder, and get our minds around a concept quicker and easier. Right, maths is practice. Hope you have a great day.